Hey guys, today we're going to go over how to graph square root and cube root functions. Before we do that, we're going to see how we can solve for an inverse, which will give us that square root or cube root. So here we have some functions, and we're going to recall how to find the inverse. Now remember that for the inverse, you take the f of x, which is actually a y, and you interchange the x and the y. So first, this equation would then become x is equal to 3y squared. Then we solve for y. So I would have to divide the 3 first. So I get y squared is equal to x over 3. And then I would square root both sides. So y is equal to the square root of x over 3. But remember that because this is an inverse, we have to use the proper inverse notation, which is where you write f with the exponent -1. That means the inverse of f of x is equal to the square root of x over 3. Let's try that again over here. We have f of x is equal to 1/2 x to the third. So remember that f of x is y, so this is y equals 1/2 x to the third. I change the x and the y, so x is equal to 1/2 y to the third. And now I'm going to solve for y. So first I need to get rid of this 1/2, so I'm going to multiply by 2 to both sides. So I get 2x is equal to y to the third. And now to cancel out that exponent, we need to apply the appropriate radical. That's not the square root because that's for when the exponent is 2. To cancel out this radical, we would apply the cube root to both sides, which the cube root looks like a square root, but then we write that little number 3 in that spot, indicating that it is a cube root. So this means that the inverse is equal to the cube root of 2x. Let's do another square root. We have f of x is equal to x squared minus 7. So this is y is equal to x squared minus 7. Interchange the x and the y, and we get x is equal to y squared minus 7. To solve, I would have to add the 7 first. So I get x plus 7 is equal to y squared. And then to cancel out that exponent, we're going to square root both sides. So that means that my inverse is equal to the square root of x plus 7. Last one, this is y is equal to 4x to the third plus 9. Interchange the x and y, we get x is equal to 4y to the third plus 9. Subtract the 9 to both sides, we get x minus 9 is equal to 4y to the third. Divide by 4. Remember that we have to divide everything on the other side by 4. So this is y to the third is equal to x minus 9 all over 4. And then we cube root both sides. And it would have to be the cube root of the entire fraction. So the inverse would be the cube root of x minus 9 over 4. So all of these functions here, we have square root functions and we have cube root functions, which that's what we're going to look at how to graph today. So let's start with the square root function. First, we're going to fill out this table and then we're going to plot the points to see what the graph will look like. If x is equal to 0, then I plug it in here to get the y. The square root of 0 is 0. If I plug in 1, the square root of 1 is 1. If I plug in 4, the square root of 4 is 2. And if I plug in 9, the square root of 9 is 3. So now these are my coordinates. I'm going to plot them here. We have 0, 0, 1, 1, 4, 2, and 9, 3. So this is the square root function. Now, the square root function is just this. There is nothing on the left side of the graph. So if I want to find the domain of the square root function, remember that domain is from the left side of the graph to the right side of the graph. Here, my left side of the graph, the smallest x is 0. And you see how we have a point there, so that 0 would be included. So I would use a bracket, 0, and then it opens forever to the right, meaning that it's going to go through every positive x, so positive infinity. Now this follow-up question says, why do you think the domain is limited to only real numbers greater than or equal to 0? And the reason why the graph starts at 0 and goes to infinity is because, keep in mind, if you were to plug in, let's say, a negative x value, if I plug in -1, this would give me the imaginary unit I, which I cannot plot here. So any negative x value would give me that imaginary number. So that's the reason. Because plugging in an x that is less than 0 would give us I. And I is not a real number, so it cannot be graphed. Lastly, here it says, describe the end behavior of the square root function. Normally, with our graphs that we've done before, we would have two end behavior statements. One, where the x is approaching negative infinity, and the other where the x is approaching positive infinity. However, if we look at this graph, the x will never go past 0, so there is no end behavior for the left side of the graph because it doesn't go to the left side of the graph. It only goes to the right. So our end behavior for the right side would be as x is approaching positive infinity because the graph opens to the right, the y values f of x is approaching, and even though it looks like it's leveling out, this graph will forever keep going up and up and up. And if it's going up, those y values are going towards infinity. Now, we're going to look at how to find the domain and range of any radical equation. So let's start with this first one. In order to determine the domain of a square root function, keep in mind what we talked about here. We cannot have a negative number inside of the radical because then I end up with an imaginary number. So anything that is inside of the radical has to be greater than or equal to 0. It can't be a negative number. So we take that x minus 4 and make it greater than or equal to 0. And then what we do is we solve for x. So I'm going to add 4 to both sides, and I get that x is greater than or equal to 4. This is my domain, and we're going to write this in interval notation. So if you like, you can always do a number line to help you out. Greater than or equal to means the 4 is included, and it's all the numbers to the right of 4. So the domain would be starting at 4 to infinity. Now for the range. The range is determined by how the graph was shifted up or down, since the range will tell you the smallest y value to the largest y value. On the parent function, which is the one that we graphed here, the smallest y value is 0. So if we think about our transformations, if it was shifted up, then the smallest y value would be whatever that number is. If it was shifted down, same thing. So what we do to figure out the range is that since the graph is opening upwards, it would be y is greater than or equal to, and then we look for the translation that made the graph go up or down, which here it's going down 1, so y is greater than or equal to -1. So the range, if it starts at -1 and then it goes up forever, would be from -1 to infinity. Let's try that again. The domain. We take what's inside of the radical, which is called the radicand. So the -2 times x minus 3, and make it greater than or equal to 0. And now we solve. So first I'm going to have to divide by the -2. When we divide by a negative, that means that the inequality symbol changes direction. So it's no longer greater than or equal to. Now it's less than or equal to. And 0 divided by anything is 0. Then we add the 3. So x has to be less than or equal to 3. So if I put this on my number line, we have the 3, which is included, but x is less than 3, so that's to the left. So that means that the domain would start actually from -infinity until 3. Included. Now the range. The range will always be y is greater than or equal to whatever number is added or subtracted at the end, since this means that the graph was shifted down 2. So y would be greater than or equal to -2. So -2 is included, and it's everything to the right of -2. So bracket -2 to infinity. Last one. To get the domain, we're going to take the radicand, so the 1/2 x plus 1, and make it greater than or equal to 0. To solve for x, we're going to multiply 2 to both sides. We get x plus 1 is greater than or equal to 0 anyway, because 0 times anything is 0. And then we subtract the 1. So x has to be greater than or equal to -1. So -1 is included, and it's all the numbers to the right. So the domain would be starting at -1 to infinity. Now the range, however. Here I put, if there is a negative in front of the radical, you must flip the inequality when finding the range. And the reason why is a negative in front of the radical indicates that there is a reflection across the x-axis. So if the graph was originally like this, then it will flip over and it would come down. So the range would actually start from -infinity, because it would decrease forever, up to the number that it was shifted to. So we have a negative here. So that means y would have to be less than or equal to -3. So -3 is included, and it's everything to the left. So from -infinity to -3. Now let's just review our transformations before we get into the graphing. For each of these equations, we're going to state the transformations on the parent function. And I put here as a reminder anything that is inside of the radical, because now it's not parentheses like we have seen in our previous examples. Now it's anything that is inside of the radical with the x will affect the x values, and you must do the opposite operation. And whatever is outside of the radical will affect the y's, and you do the same operations. So here we have a +2 inside of the radical, so this means that the graph was shifted to the left 2. Then we have the -3 on the outside, so this means that the graph went down 3. Over here we have a 1/2 on the outside of the radical. Remember, anything that is being multiplied outside is a vertical dilation, and because this number is less than 1, this is a vertical shrink of 1/2. Then we have this -5, so that means that the graph was shifted to the right 5. Over here we have -4 square root of x plus 1. There is nothing inside with the x, so there are no transformations being applied to the x values. But we have this negative on the outside. And a negative on the outside means there is a reflection across the x-axis. We have the 4 that is being multiplied on the outside, so this will be a vertical stretch of 4. And finally, this +1 on the outside means that the graph was shifted up 1. Now last one here, we have the square root of -3x. Here, everything is inside of the radical. There is nothing on the outside, so that's not going to affect your y values at all. The negative on the inside means that there is a reflection across the y-axis. So this is the only way we're able to have negative x values in our radical is if there's a reflection across the y-axis. Because if our original graph looks like this and there's a reflection across the y, that means it would look like that, and I'm able to plug in negative x's inside the radical. And then you would have a negative times a negative, which would give you a positive y value. Finally, this 3, any number that is multiplied or divided to the x is a horizontal dilation, but remember it's the opposite. So instead of multiplying 3 and making the x's bigger, it's actually dividing 3, making the x's smaller. So this is a horizontal shrink of 1/3. Now that we've reviewed our transformations, let's look at how to graph. Here we're going to use the reference points 0, 0, and 1, 1. So as long as you know where these 2 points are, like the new ones, then you can just continue the curve. However, you can always use more points if you like, keeping in mind that any of these here, the 4, 2, and the 9, 3 are other reference points. But we're just going to use these 2, and which eliminates more work for you. So here we have this equation. Let's write out the rules using our transformations. So remember, anything inside of the radical affects the x and will be the opposite. So we have this -1/2. Instead of dividing 2, we're going to multiply 2. So it'll be -2, then x plus 2. The +1 is on the outside, so this affects the y's. So this will be y plus 1. Now we use our reference points, 0, 0, and 1, 1. When I plug in 0, 0, -2 times 0 is 0, plus 2 is 2. And 0 plus 1 is 1. Now when I plug in 1, 1, -2 times 1 is -2, plus 2 is 0. And then 1 plus 1 is 2. So I'm going to plot my points here, 2, 1, and 0, 2. So follow the direction of your points. This was the first one, this is the second, so that means that my graph is going to open like this. And you can also use your transformations to kind of understand the graph, right? This negative means there was a reflection across the y-axis. So instead of looking like this, it looks like that, which is why it's facing that way. Now we can use the graph to find the domain and range, or you can use what we did earlier, whatever you prefer. I'm going to use the graph here so you understand. For the domain, it's always smallest x to the largest x. So we read the graph from left to right. This graph is opening forever to the left, so that means that the domain will start with -infinity, and then the largest x value is 2. And that 2 would be included. The range is the smallest y value to the largest y value. My smallest y value is the 1, which is included. And then the graph is going up, so it would go up to infinity. And again, if you use what we did earlier, if we take the inside of the radical and we make it greater than or equal to 0 to solve for the domain. I would have to multiply -2 to the other side to cancel out the -1/2. And that would give me x minus 2 is less than or equal to 0, since I multiplied a negative that changes my inequality direction, and then add 2. So I get that x is less than or equal to 2, which if you put that on your number line, the 2 is included and it's everything to the left, which matches my domain here. And then for the range, there's no negative in front, so this would be y is greater than or equal to this number, which is 1, which matches my range. So whichever method you prefer to use is fine with me. You can use the graph or you can use the rules that we did earlier. Let's practice that a little more. Here we have g of x is equal to -3 square root of x minus 2 plus 3. So let's write out our transformation rules. The rule for the x would be x plus 2. And the rule for the y would be -3y plus 3. We use our reference points 0, 0, and 1, 1. When I plug in the 0, 0, 0 plus 2 is 2. Then -3 times 0 is 0, plus 3 is 3. Finally, when I plug in the 1, 1, 1 plus 2 is 3. And -3 times 1 is -3, plus 3 is 0. So we're going to plot our points. We have 2, 3, and 3, 0. Remember to connect your points as a curve and following the order in which you plotted them. I started with the 2, 3, so that means that it's going to open down and curve. For the domain, I'm going to use the graph, but remember that you can also use the equation to find the domain and range. The domain, the x, starts with 2, and the 2 is included. And then it opens forever to the right, so to infinity. Now for the range, it starts from -infinity because it's going down forever. Remember that we always start with the smallest y value, so that's why for the range we read the graph from the bottom up. So that would be from -infinity, and then it goes up to the y value of 3, also included. Now let's do this one here. We have g of x is equal to the square root of 1/3 x plus 2 plus 1. So let's write our rules. The rule for the x's is everything inside of this radical. Instead of dividing 3, we're going to multiply 3, x, and then instead of plus 2, we use minus 2. For the y's, we only have the plus 1 on the outside, so that would be y plus 1. Now we use our reference points 0, 0, and 1, 1. When we plug in 0, 0, we get 3 times 0 is 0, minus 2 is -2, and 0 plus 1 is 1. Now when I plug in 1, 3 times 1 is 3, minus 2 is 1, and 1 plus 1 is 2. So I'm going to plot those points, -2, 1, and 1, 2. Remember to follow the order. I started here, so I'm going to go towards that second point, and it's going to curve that way. So my domain, the smallest x value on the left side is this -2, which is included. And then it opens forever to the right, so to infinity. Now for the range, the smallest y value is 1, and it opens forever going upwards, so to infinity. Now let's look at the cube root function. So the cube root of x is basically any 3 identical numbers that would give you, for example here, the -8. So if I'm trying to find the cube root of -8, Basically, we can have a negative inside of this radical because there are three numbers that can multiply to give you negative 8. And those three numbers would be negative 2, negative 2, and negative 2. Negative 2 times negative 2 is positive 4, but times that third negative 2 is negative 8. So the cube root of negative 8 is negative 2. Basically, if you have a negative inside of the cube root function, the answer will be negative. And the cube root of 1 times 1 times 1 is 1. The cube root of 0 is just 0, and the cube root of 1 is 1. The cube root of 8 would be 2. So now let's plot these points. We have negative 8, negative 2, negative 1, negative 1, 0, 0, 1, 1, and 8, 2. When we connect these dots, it must be curved. So it's going to look something like, kind of like an elongated S, like that. For the domain of the cube root function, it opens forever to the left, it opens forever to the right, so the domain is negative infinity to negative infinity. For the range, even though we only see a little bit here, if I keep going to the right, the graph is increasing, it'll go forever up. And if I keep going to the left, the graph will continue to decrease, going forever down. So the range would also be negative infinity to infinity. Now, why do you think we can have a negative number inside of the radical? And this is what I explained here. And the reason for that is because three identical numbers would multiply to give you a negative. So now let's look at how to graph these. For the cube root function, we're going to use these three as our reference points. Negative 1, 0, 0, and 1, 1. So now here we have the function g of x is equal to the cube root of 1/2 x minus 3 plus 4. So let's write out our transformation rules. The rule for the x would be 2x plus 3. And the rule for the y would be y plus 4. So now we use those reference points and we plug them in. When I plug in negative 1, negative 1, 2 times negative 1 is negative 2, plus 3 is 1. Negative 1 plus 4 is 3. Now we plug in 0, 0. 2 times 0 is 0, plus 3 is 3. 0 plus 4 is 4. And finally, when you plug in 1, 1, 2 times 1 is 2, plus 3 is 5. And 1 plus 4 is 5. So we're going to plot these 3 points. 1, 3, 3, 4, and 5, 5. Your points will kind of look like a line, but we already saw what the graph looks like. It looks like an elongated S. So we have to make sure that we follow that curve. So it's going to look something like that. And the domain and range for all of these is always negative infinity to infinity, so I'm not going to be asking you too much about that since it's always just negative infinity to infinity. Let's do one more. Here we have the equation negative 2 times the cube root of x plus 1 minus 3. So let's write out our rules. Remember, anything inside of the radical will affect the x, so this will be x minus 1. Anything outside of the radical affects the y's, so negative 2y minus 3. Now we plug in our reference points, negative 1, 0, 0, and 1, 1. When I plug in negative 1, negative 1 minus 1 is negative 2. Negative 2 times negative 1 is positive 2, minus 3 is negative 1. When I plug in 0, 0, 0 minus 1 is negative 1, and negative 2 times 0 is 0, minus 3 is negative 3. Finally, when I plug in 1, 1, 1 minus 1 is 0, and negative 2 times 1 is negative 2, minus 3 is negative 5. So I have these 3 points. I'm going to go ahead and plot that. Negative 2, negative 1, negative 1, negative 3, and 0, negative 5. So now we have to make sure that we follow the curve, which again is like that S. So it's going to look something like that. And this would be our graph. And just like I mentioned in the previous example, the domain and range for all cube root functions is always negative infinity to infinity, and the range as well. And that's graphing square root and cube root functions.